Hello everyone, welcome back to my channel. This is episode 3 of our Python for AI series. In today's episode, we'll explore the history of programming language, understanding the concepts of compilation and interpretation, and I'll try to guide through the installation part of Python and setting up the Visual Studio Code for Python development. So let's start. Let's take a look into history of programming language, right? Fine. So, see, when it comes to the programming language, it is having a rich history. It is evolved to meet the demands of the latest technology, right? So, here are the some key milestones for the evolution of programming language. I'm gonna write one by one and explain later on. Right. So, when it comes to the first programming language, it was, I hope we are aware of it. So, because when Charles Babbage has invented a new computer, uh, we know that the very first programming language was machine learning language, or binary language. So, I can just tell it is nothing but it is nothing but bits. Okay, so we'll be having binary code. For example, like 0 1 0 2, like this. Fine. So this was the first programming language when Charles Babbage invented the computer, and it is used to compute the Bernoulli numbers. Fine. So next, there is something very important, as well as the I can tell it was a very good development in programming language history. There is something called as assembly level language. So it was invented in 1949. It was a low level language using the symbolic instructions to understand by machines. So for example, I can just tell something like this. So what I'm trying to tell here is this is an example of assembly level language. So I'm just mentioning here load this variable called as AL, with 97 decimals to 61 hexagon. Right. So I know that it's like you're not able to understand. So basically, what we are telling is when it comes to assembly level language, we have to specify everything. Like it since it is a low level language, so we have to specifically tell. We have to tell something like we have to load the variable, and again we have to assign the bits to the variable, right? And again we have to create a pointers to store in the memory. A lot of things has to be done. So at that point of time, it was very useful. Okay. Next, later on, they invented autocode, where this is the first compiled programming language, which was very important, which led to invention of COBOL as well as Fortran. Okay. So when it comes to here, Fortran was invented in 1957. It was created specifically for computing scientific calculations. So it was mostly used in NASA space probes, right? Next, we are having something called as ALGOL, ALGOL. Fine. So this was the first programming language where it was uh, introduced like nested functions and structured syntax, which was very inspiring to develop C, C++, and Java. Okay, and COBOL. So when it comes to COBOL, it was a very first programming language which was used for business use cases. So it is used to design the applications for business. So it was very famous in such a way that like 80% of the businesses were using in their systems, right? And very important thing, basic. So this basic made a programming accessible to beginners. So later on, which was like leading to evolution of Microsoft Visual Basic as well, right? Next, we all know C programming language. Who doesn't know C programming language? So it was developed by Dennis Ritchie in the year of 1972. I hope you are aware of C programming language. If you're not aware, let me just give a brief introduction to it. It is the first programming language which was very popular, and I can just tell it is a which was general purpose programming language that replaced assembly level language. Fine. So which was a basic foundation for C++, Python, and Java, right? So this was a brief history of programming language. Fine. So now what I'm going to do, I'm going to explain more about the uh, I can just tell working of this machine level language, assembly level language, as well as C. We are not going to cover all these things because not so important as well. Why? Because when it comes to Python architecture, like internal architecture, these things are most important, right? You not explain and you not understand. Fine. So as I told initially, we know that a computer cannot understand human language, right? So it can only understand one language, that is binary or machine level language, I can just tell. Right. So imagine I'm writing a machine level language. Maybe like we know that it was the first programming language. We assume, let us go back to 1940s. So since we know that computer can understand this machine level language, so we can just give this code directly to the computer. So what happens? I'll be getting the output. Means the output is displayed, given out by the computer. Right. It was very easy, simple. But as days goes on, we know that the second most popular language was assembly level language, which was the first low level language, which we used to give some symbols, like giving some instruction to the computer, right? Right. So here, as I told, let me just write an example for assembly level language, something like this. So it was basically it was the symbols like move, message, and copy. So these things, right? So what I'm going to do, I'm going to just give this to my computer. Definitely it cannot understand. Why? Because it is almost similar to English, right? So here what happens is, since the computer cannot understand here, we cannot execute this. So that is where a special software come into picture, and the special software is something called as assembler. So this assembler is a system application which converts the assembly level language to machine level language, right? So then this machine level language is given to the computer. We'll be getting the output. So this was a process, this was an evolution of programming language. So again, so we know that again we have a lot of other programming language, right? Like autocode, Fortran, COBOL, basic. But let us slightly go into C and C++. So when it comes to C and C++, we know that I'm not going to write a complete program of C. I'm gonna just write something like simply like source code. So what I'm going to do, this is my source code, or this was a first high level language, right? Fine. So I'm going to give this source code to my computer. Definitely it cannot understand because it is also similar to English. But again, we won't use this assembler as well. But what comes in into picture here? So there is something called as, again there is a system software. We call it as a compiler. So this compiler comes into picture. See, what is this compiler? It is a system software which converts the high level language to the machine level language. right? And in between lot of process will happen, we don't want it in detail, right? So this machine learning language again is given to a computer, it is taken as an input to the computer, it is giving some output, right? So this is the evolution of a programming language till C, right? So C is a high level programming language. Without any doubt, it was a best programming language at that point of time. But there are some disadvantages when it comes to C programming language. The main disadvantages are, so these are the limitations of C programming language. So it was having something like manual memory management. So where C requires a developer to manually manage the memory allocation as well as deallocation, which led to memory leaks and some other disadvantages as well. So again, it is having some lack of built-in safety features, like C lacks built-in protection against common errors such as buffer overflows and null pointer exceptions. Fine. And very important thing, right? So this is a very important thing. C is a platform dependent. This was the main disadvantage, right? So for example, if I'm developing an application in Windows operating system, I cannot execute the same program in the Mac OS. That was a, that something was stopping here. Something is nothing but platform dependent. It is completely depend upon the OS operating system. Mean this compiler is nothing but it is dependent upon the operating system, right? So this machine level language, if I'm giving to for example, if I'm having some source code in Windows operating system, I'm compiling that code in the Windows operating system, it is generating some machine level language. But what I'm going to do, I'm going to take this machine level language and imagine it's a Mac, it's a MacBook, okay? I'm going to give this machine level language to the Mac OS or the MacBook. What it does is, this does not support, means this machine level language is not executed in the Mac OS. Why? Because this machine level language is platform dependent. Don't you think that it's a biggest disadvantage in this era? Why? Because we're having a lot of different multiple OS, right? Imagine if I'm telling I'm developing an application in Windows, you cannot use it in Mac, you cannot use it in Linux, right? That doesn't make sense. That was a very biggest disadvantage. Fine. And it is having a complex syntax. And again, one of the second disadvantage is nothing but it is not a object oriented programming language, right? So C is not oops language, which makes very difficult to reuse the code. Again, there are a lot of disadvantages are there, okay? Fine. So this was the main thing, or the limitations of C programming language, which stopped to build an applications using C. So that is why there are other high level programming language which came into existence, or which they built, like C, Java and Python, right? So I can just tell this process is nothing but compilation. Example of compilation. So let me just try to write a definition for compilation. See, compilation is nothing but it's the process of conversion of high level language to the machine level language in a single shot. Mean within a single go, completely it is able to convert, right? Okay. So this is the definition of compilation. Then what is the meaning of interpretation? The meaning of interpretation is the conversion of the code, some code, by line, right? I'm going to explain that as well. Okay, so before that I need to write a diagram, right? So here, see, this Python is also a high level programming language, right? So the Python code is converted with the help of Python compiler or compiler, and the result is not machine level language. Instead of machine level language, we will be getting something called as bytecode. So what is this bytecode? Bytecode is nothing but it is a combination of high level language and machine level language. Right. So I can just tell this is a Python compiler. So here the bytecode which is generated is something like this. Okay, fine. So this bytecode is taken as an input to one more system software. See, this system software is called as PVM, Python Virtual Machine, right? It is a PVM, Python Virtual Machine, right? And this PVM is taking the input from the input as a bytecode, and it is converting line by line, not in a single shot. So what is happening here? It is taking everything in a single shot. It is converting to a bytecode. But when it comes to this PVM, Python Virtual Machine, it is converting this bytecode line by line. Okay, it is going to take first line. It is going to convert the bytecode to the machine level language. Okay, then again it is coming back again, right? Again it is taking second line, it is converting to the second line. Next again it is a step by step process, line by line execution is happening here. So this process is called as interpretation. Okay. So this is my machine level language, right? And this machine level language is given input to my processor, that is my CPU, or I can just tell processor, right? And the processor is giving to the some operators, lot of things are happening, and I'll be getting output. Fine, let us assume. Fine. So here try to understand very carefully. This machine learning language is platform independent, right? Platform independent in the sense I can just give this machine learning language to any OS, it will be able to execute, right? So why? Because I can just tell, I can write one more diagram as well. Right. So what I'm going to do, each and every operating system will be having their own PVM. Okay. Fine. We are not going to give this machine level language. We are going to give this byte code to here, to here, to here, and this in turn will return machine level language, right? Machine level language here, and it is going to proceed further. It is going to give to the microprocessor, and it is will be getting the output. So this is what happens, and this is the reason why Python and Java is very famous, as well as it is called as platform independent programming language, right? Platform independent programming language. So that is the reason a lot of applications has been built using Python and Java, right? So let me just write the explanation or definition for interpretation. Fine. So the process of conversion of bytecode to machine level language with the help of PVM or Python interpreter line by line is called interpretation. Fine. So again, Python is also called as hybrid programming language. If you have watched my previous video, I have explained that there as well. So I told in Python there is two processes going on, compilation as well as interpretation. So this phase is called as compilation, right? So compilation, and this process is called as interpretation. Fine. So this is the reason it is called as hybrid programming language. Fine. So we have learned the different types of programming language, as well as we have learned the architecture of Python. Or I can just tell execution of Python program, right? So this was the process. Fine. So I hope it was really interesting. Let me just write a few more points as well. So when it comes to this source code, so I'm gonna write this thing, okay? Source code, bytecode, machine level language. See, source code is platform. I'm gonna write shortcut, okay? Platform independent. So whereas bytecode is also platform independent. But when it comes to machine level language, it is always platform dependent. Got it? Fine. Uh, so yeah, that's it for today's video, guys. Uh, I hope you have enjoyed the session. So thank you for joining me in this episode. We have learned the history of programming language and understood the compilation as well as interpretation process. So don't forget to like this video, subscribe to my channel, click the bell icon to stay updated. If you have any questions, feel free to leave them in a comment below. See you next time, and happy coding.